The factor by grouping method, you want to group your terms in two groups so that each group has a common factor. Factor out the greatest common factor for each group. And if there is a common binomial factor, factor that out. If not, rearrange your terms and try these steps again. So our first example, we want to factor this by grouping. So I'm going to group the first two terms together and the second two terms grouped in pairs. And I'm going to look just at the first group and see what they have in common for those two terms. So 15 and 10 share a factor of 5, and they have an x with the lowest exponent 2. So my greatest common factor for the first group is 5x squared. I'm going to divide that from those two terms to see what remains. For the first term, 15 divided by 5 is 3. X cubed divided by x squared is x. For the second term, I have 10 divided by 5, that's 2, and the x squareds cancel out. There's a plus sign between my groups, so whatever this sign is, this will come next. And that's why I don't use parentheses to group these. And I'm going to look for greatest common factor for the second group. So 6x and 4. 6 and 4 share a factor of 2, and that's all they have in common. So let's factor 2 from those two terms. 6x divided by 2 is 3x, and negative 4 divided by 2 is minus 2 here. So now I have two terms still. And I want to see if these two terms have a common factor. They do have a common binomial factor of 3x minus 2. So I'm going to factor out the 3x minus 2 from both of those terms. And then let's divide to see what remains. It's going to cancel out multiplicatively, leaving 5x squared for the first term plus 2 for the second term. And that is the factored form of that polynomial. Our next example, I'm going to group these by 2, see if there's a GCF for the first group, and there is not. A GCF for the second group? Not really. So this is why I probably want to rearrange my terms, so that I have a common factor for each of the groups. So I'll start with 3xy and say, let me move that minus 3x, then the minus 2y, and then the plus 2. I'll just rearrange those terms. Okay, so let me group these again and see a greatest common factor for the first group is 3x. So let me factor 3x from those two terms and see what remains. The first term, if I divide the 3 and the x, I'm left with y. For the second term, it divides and leaves just 1. There's a minus sign between the two groups, so the greatest common factor has a negative. And they share 2, so we'll be dividing a negative 2 as we factor out a negative 2 from these two terms. So that will leave a positive y for the first term, and 2 divided by negative 2 is negative 1. So now my two terms here, they do have a common binomial factor of y minus 1. So let me factor that out from these two terms and divide to see what remains. It's going to cancel out, leaving 3x for the first term, minus 2 for the second. So that will be our factored form for this polynomial. Our next example, I'm going to group these in pairs and see what the greatest common factor... Oh, hold on. Maybe I'm going to do something else first, and that is there a common factor for all of these terms? Because if there is, I want to factor that out first. So let me see. 90, 15, those share a factor of 3. 3, yep, there's a 3 in all of these terms. I want to factor that out. No variables because the first term has no variables. So 3 is the most they could have in common. So let me factor 3 out of this first. So I'll divide to see what remains of these terms. The first term, that'll be 30. Second term, that divides to 5. y squared. The third term, that's a minus 6x and minus xy squared. Okay. So I got to get that GCF out first. And then let me pair these up and find the GCF for each of these groups. So the first group, these two terms have a 5 in common. Okay, so I'm going to factor 5 out of the first group. So divide that from each of those terms. That leaves 6 for the first term and y squared for the second. A minus sign tells me that the GCF of the second group will be negative. And they share an x. So minus x is the greatest common factor. That's what I'm going to divide from those terms to see what remains. For the first term, that'll be a positive 6. For the second term, that'll be a positive y squared. So now I'm going to look at these two terms that remain and see if they have a common binomial factor, and they do, 6 plus y squared. So I'm going to factor that out. And let's see what remains of these two terms. For the first term, when we divide that common factor, it leaves us 5. For the second term, when we divide, that leaves minus x. So don't forget your GCF out front. That is part of the factored form.